Welcome to an overview presentation of SolidWorks Inspection. SolidWorks Inspection is a new product to the SolidWorks family, and it's used for generating the first article of inspection documents for companies. Now we're going to go through the interfaces in a couple of different ways here, but I want to just be very clear with the tool. When you buy it, there's actually two different ways you can interface with files. There's a standalone application, and then there's a SolidWorks embedded add-in. Now you get both of these when you buy SolidWorks Inspection. The purpose of them is a little bit different though. However, the standalone application is used for marking up PDF documents. So in that case, it wouldn't really matter what CAD system of origin the files came from. PDFs are generic in nature. There's also a professional aspect. So there's SolidWorks Inspection Standard and Inspection Professional. And with the Professional module, you can link directly to things like coordinate measuring machines or read files from coordinate measuring machines or directly to capture measurements from digital calipers. So both of those are available, but once again, the standalone application is PDF markup. Can also have the professional module part of it, as well as the SolidWorks add-in, which is going to work on SolidWorks native files. So we're going to start this presentation out actually by looking at the standalone application. The interface itself is pretty simplistic. There's a few tabs across the top and a minimal amount of tools, but a maximum amount of result from this. And along the bottom we have this area called the Table Manager. There's three tabs associated. One's the Bill of Materials, another one's called Specifications, and then the last one here is called Bill of Characteristics. And these all have to do with the standard known as AS9102. These three areas really represent Form 1, Form 2, and Form 3 of that standard document. So we'll cover that as we get deeper within the software. We start using the standalone application by simply starting a new project. So up here across the top, when we say new project, we have templates that can be customized and preset so that you can start from those points, much like you would with the SolidWorks part, assembly, or drawing. We're going to start with our inch template. And at that point, it prompts us to read in a PDF document, but it could also be a high-quality TIFF image from any software whatsoever. We're going to start in a standalone application, and we're going to get the first version of this PDF of this lower plate. And you can see in the preview window, we can tile through the different pages part of this PDF document. As we open the file, we'll see obviously the preview of the document over in the graphics area. And then on the left-hand side, much like SolidWorks, we have a Properties Manager. Now when we're looking at this file, it's just a PDF, so we can navigate through this. We can also go ahead and click between page 1 and page 2 down here at the bottom. So navigation is pretty simple that way. You can also use your scroll wheel and actually scroll down to the second page just by scrolling vertically and horizontally. There are also auto-fit buttons. For our purposes, we're going to zoom in a little bit because that's going to make it easier to go ahead and grab the graphics that we're seeing off of our sheet. But in this case, we can go ahead and zoom to whatever size suits for whatever we're trying to do. So in the beginning, what we're going to do is actually capture a bunch of things from this PDF. After all, it's more or less an image at this point. And we could do that by either manually typing in things like the part number, the part name, and the revision, or if we find that data directly on the drawing, we can actually capture it by using screen grabs. So with a simple window select around these items, it's going to grab that data and automatically pull it in. So let's go ahead and get the part number down here as well, and then we'll get the revision as well, A1. Want to make sure we grab these as close as possible so that we don't have any extra points or geometry around there. If you were to grab a dimension, for example, and maybe grab part of this leader, it might see that as a minus symbol for some reason. So that's what we want to look at there. We could go ahead and deal with other things like the material and other information if we'd like to place that in there. But at this point, we're just going to go ahead and stick with the three captured properties. From there, what we want to do is go ahead and deal with the other data around the drawing. And these are going to be our characteristics. We'll capture those by using the same types of techniques. We'll bring out our Characteristics tab. And then with that, we're going to use our tools to grab these. We can be specific to dimensions, geometric tolerances, notes, surface finish, and weld symbols, as well as other things. We're going to start off by using notes. Again, we want to grab these as close as possible. So with your cursor, we want to get in there, we want a window around it, and we want to grab just the text itself. And as you do that, it should optical character recognize that very well if you've grabbed it properly. So same type of thing here. We don't want to grab any extra geometry around it. We just want to get the words as they appear. And anything extra might wreck the capture. So there we see those three captured quite nicely. Then what we want to do is go ahead and get into the dimensions themselves. So again, using another tool or using our hotkeys, as you can see from the tooltip here, Control-D, Control-G, Control-N, very predictable. We're going to grab our dimensions. So same thing here. We just want a window as close as possible around those, and as it does, it will do a screen grab, optical character recognize that screen grab, so we want to be sure that the capture grabs only what we need. And it's even filling out the other properties with this based on what it sees on the screen. Now left to right, right to left don't matter. It's whatever makes it easiest to grab the data accurately. So now we can cycle through each of these. Using the tools here, we can see all the data that's been captured. As we grab those, they highlight on screen, or you can just pick them on screen to jump directly to those. It recognizes what it is. Type is dimension. Subtype is a linear dimension, so it recognizes the formatting. The units and the quantity are also automatically grabbed, as well as the nominal value here. Now you see the tolerance, the plus or minus, was also captured here, and with that it calculated the upper and lower limits automatically. So it's a nice little screen capture that it gets as a result of that. We can also add additional inputs, things like the inspection options. And with this we can create lists of operations, so you can grab whatever is appropriate for you. The classification, how important really is this? We'll call that one major. And then what method of capture? Could do a lot of different things, and this is another customizable list because these might not be capabilities available for you. So we're going to use coordinate measuring machine. If we want to go ahead and mark this for reference or basic, we may. If we added a key dimension, then we'll go ahead and put the K next to the circle in the balloon right next to it. Speaking of balloons, there's also inputs for that as well. So let me open up the balloons area. We can change the formatting if we like. So different shapes, change our fill color if we like. I'm going to make that white, and then we're going to make our text stand out a little bit more. Let's save this project while we're in the middle of it. Sounds good. There's also some orientation controls. So as you look at different dimensions up here, we have the choice of being able to rotate these vertically or horizontally. There's also some minutia control here, so you can rotate that just slightly if necessary to get it in an off orientation or to recognize properly, as the case may be. Let's go ahead and move over to this dimension right here. Actually, the one we're looking at is just fine. And what we're going to do is modify the tolerance on this. And I want you to see exactly what this thing does. I'm going to manually modify this tolerance. In this case, I'm just going to call this a 0.05. And because of that, it's going to recalculate that upper limit quite a bit. Now, in the event that we have a capture that maybe went awry because there was too much geometry grabbed with the window or something of that effect, we can actually recapture directly from the capture up at top here. So if I grab a window around that plus or minus tolerance, once again, I have the choice of recapturing the entire value, the nominal dimension, or the tolerance dimension. And as I select it, you'll actually see that box down there fill in again properly, and it will recalculate the upper and lower limits for us. So very full-featured, very flexible though. We also have another dimension over here. This dimension has a few things going for it actually. We have a quantity that's in there. It recognized it as a radius dimension, a little bit different. There's also the fact that it's not toleranced. And I want to talk about each of those here in just a moment. First thing I want to deal with on this one is the fact that there's multiples here. Now with multiples, what you end up with is the capability to choose these as an individual quantity. And as I select them, you might see down here that we actually have the multiples showing up in this bill of characteristics as a single line item but a quantity of 2. Now with this button, I can go ahead and treat them each as individual instances, which will now give us an 8.1 and an 8.2. Now there are choices where if we multi-select those, we can actually ungroup them. That would give one an 8 and one a 9, and the result of that would actually be two separate balloons. So I can pull these balloons apart, and you'll see both of those right there. We could also control select them once again and regroup them, or group them and share the balloon again. So now they go back to number 8, everything else renumbers, and we're looking at our stacked balloons here once again. So that's an interesting part here, and also a radius. Now my template didn't grab it in this event, but what I want to show you is an option here that's part of our project, and it has to do with default tolerances. What you can do with this is actually add in significant digits, and then the tolerance that should be used in the event that it finds a dimension without a tolerance. So if I now have one significant digit, I'm going to do the same thing here. Let's do 0.1 again. Let's do 0.1 again. If I have two significant digits, maybe a 0.05 and a 0.05, and then 3 digits will give that a 0.005. And we might not need the tolerance per se when it comes to the creation of this file. But what we need to do with this is have something that's the variable for the inspector. So when they're using a mechanism like a pair of calipers to do this, there still has to be that upper and lower limits. Now if that had been preset in my template, then it would have automatically added those tolerances over here to these untoleranced values. With that, I can actually go ahead and recapture this if I'd like to, and just grab it out here from the screen one more time. or if I just go ahead and window select it right inside here, we'll go ahead and grab the entire thing, and you'll see that it actually added those tolerances automatically. So again, a lot of flexibility in what we're doing, and the capability to go ahead and deal with these dimensions as they're created without tolerances. What I now want to look at is a little bit more in the bill of characteristics. Down here you see that the balloons show up, and we're going to focus on this little area right here. This area allows you to see that there's a 9, a 10, and an 11 right in order. You could take your 10 and drop it above your 9 and reorder those numbers if you'd like. Again, very easily drag them around, reorder those back. If you get to one that you don't want, we're just going to right click and delete that. And it will actually ask you, do you want to renumber? So we won't jump right from 9 to 11. You'll see this balloon here actually switches over to 10. So again, very flexible with how that works. Multi-selects will allow you to action on multiple picked items. So down here, if we select 4 different balloons, what I want to do is actually change an inspection method for all of them in a group. So as I do that, it will automatically fill out for each of those with a single selection the inspection method. With this table, we also have a lot of flexibility when it comes to the way they're grouped. So here is all the text, which is the notes and different dimensions. With each of these values at the top, you can sort them by selecting them, and you'll get ascending and descending columns. Switch to the balloon numbers or the characteristic. Get choices that way as well. We can also filter things. So if you hit the small filter next to these column headings, I can now filter by this column by only things that are CMM. You can see that the search or the filter shows as such in the lower left-hand corner. We also have a capability to group things. So if I right-click on this column and group by this column, it will actually give you some dimensions in one method with some with our CMM method. So again, another way of categorizing those and putting them together. A right-click, disable groupings, allows us to deal with that. And if I wanted to, I could actually take an individual group like this inspection method right here, actually kick it off as an Excel spreadsheet very easily. So that would give us some control over grabbing just this series of dimensions as opposed to all of those. So kind of a neat method there. Let's go ahead and disable the grouping. I want to do some capturing of some additional characteristics here for a moment. In this case, we're going to go back to our drawing, and I want to do some geometric tolerancing this time. It's a little bit different here. It's not quite full optical character recognition. It comes in as a geometric tolerance, but essentially shows as an image of what's on the screen. Now there are things where I can go ahead and fill this in a little bit more detailed, so I can grab that this is a profile of a surface, and then maybe character recognize what we see up here. So if I want to go into this box right there, I could window select what we've got and simply add it to this box. Or we can just go ahead and fill this out manually. So those will work just fine as well. When we're dealing with the tabs down here at the bottom, we don't quite have everything we need for the full inspection document. So Form 1 is not filled out with the bill of materials. We do have Form 3. And again, this is the AS 9102 standard that we're dealing with on this. So what I want to do is go ahead and bring in some additional information here to fully fill this out. Now to do that, I can either go ahead and import a CSV file, which is one method of bringing this information in. What I can also do on this one, though, is go ahead and bring up another document. So right now we have a single PDF within this file. So at this point, what I'm going to do is just simply add a drawing. And I'm going to grab one here that's going to represent a parts list. Now when I open up this drawing, let's just zoom that so we can see the whole thing. I want to use this to fill out my entire bill of materials. So to do this, I'm going to extract it. I'm going to do it by just putting a window around the data. And in typical optical character recognition form, it's going to bring all of these in. I just simply have to tell it what these columns represent. So in this case, we're going to use that as a part number, use that as a serial number, and we'll use this as a part name. And then that will fill out my bill of materials down here. So as far as that goes, we now have the fully capable file that we can then go ahead and export. So with this, let's go ahead and take a look at two more things and then actually show the final output document. If we go back over to our sheets here that have the drawings, there's a couple of nice filters to make sure that we've done everything. This is, again, a pretty simple document here visually, but there are some issues where you might want to be able to filter a very large document out to find out what you've done or not. And up here we have in the Simple View tab is something called Hide Captures. It gets rid of everything that is currently captured, therefore it isn't as obstructive on the screen. And that will allow us to see things that maybe we've missed. So if I go back and capture this guy right here, that I can grab him. He will come in as a characteristic. And then from there, if I simply go ahead and show my captures and then rehide, you'll see that that one gets masked out as well. There's also a situation that happens with change. Now, I've always said the only thing constant about design is change. So here, if a change takes place, we want to be able to compare this file with the new file. Typically today, this is done very manually. 2 PDFs that are printed out, a gentleman or lady with a colored pencil or highlighters, going from one to the other to make sure that this is yes, the same on both drawings, or no, this has changed. It's a very, very manual task. A lot of opportunity for some incorrect input there. So we're going to use our compare tool for this. In this case, it's going to prompt us for a new version of the PDF file. So we're going to go from the A version we have now to the D version. And as I go ahead and open this up, the comparison will take place by highlighting things that are in the original document in red, and then things that are new from the new document showing in green. Very clear that these show up on the screen in this respect. So you can see each of those quite simply within the screen. You can either replace the file with a new PDF if you'd like, or we can just continue on with what we're doing here by closing the tool out that we have right now. So both of those work quite nice. The other thing that we need from a visual standpoint is, again, on a more detailed drawing, more critical, but here we're going to do this from a standpoint of just showing the quality of this, is adding the grid system. Now, a grid is a very typical thing that we see in a CAD file. And when you take a look at this, we have 1, 2, 3, 4, 5 along the bottom of the SolidWorks document. So we want to mimic that here. We're going to say how many columns do we want. It's going to be 5. That's great, but they don't quite line up. So we'd want to use this button up here to actually change it to a physical changeable size, which in this case I want to be just within the title block itself. We don't want the entire piece of paper represented by this. And then that'll make our grid lines line up in a much more accurate way. What I also want to do is change the text. We have a 4A, a 4B. That's not quite right. For our columns, I actually want that descending, 5, 4, 3, 2, 1. And at the top, we'll do an ascending list of A through Z. So that'll give us a nice quality look here. We can choose what sheets have this as well. So if you look over at sheet number 2, that currently does not have it turned on. We can choose it to be there or to not be there. And I'll have it on both of my sheets, but I certainly don't want it on the parts list. We'll keep it off of there for now. So right now we'll go ahead and take what we've got and simply say OK to that, and that'll create our grid lines. So at this point we'll go ahead and export this to Excel. Up at the top we'll just simply select one of our templates, and we have several here, including one that I've customized, so you have every opportunity to make these exactly what you'd like. We're going to use just a text version of this right now, and as I click Export, it'll now generate our Excel spreadsheet. This will have all of the Form 1, Form 2, and Form 3 information, so as we look closely at this, you'll see that we have our Form 3 showing right now. This is all of our inspection notes, the ranges that they happen to be there, and the inspection method. Form 1 is our full bill of materials, nicely formatted, including the properties of the file itself. And then Form 2 doesn't have anything in it in this case. That's more of a raw product accountability type of a document. But very, very good there. Now I'd like to take this to the next step and show you a little bit about the professional property or product as well. So what I want to do here first of all is just turn off the grid system. Don't need to see that for our purposes right now. And that all looks fine. And then with that I want to go ahead and just bring in the professional stuff for a second. So let's go ahead and switch over from standard functionality now to what professional offers. In this case there's going to be some nice measurement capabilities and CMM capabilities that we're going to do with this. So down here what we get, at least on the right side I'll say first, is the CMM Data Import. We'll come back to that in just a moment. But what we also get down here is an area down near our 3 tabs in the Table Manager for measurements. This allows us to actually interact with everything that we see here. So if I add a new column here and do something like this, for example, let's just say the word pass, you'll see that it turns green and it color codes the actual note up here on the file. So we're going to do a pass on this one, and then let's go ahead on this next one. Let's do a fail. Fail is going to show in red, and that should show very clearly on the drawing. Next one down, we have a file value here. Let's see. Upper limit is going to be 345. Lower limit is going to be 305. Let's go ahead and type 0.305. Take a look at that. It shows up in yellow because it's right there on the border. This one here, we're going to type 0.315. 0.315. Oops, that's for the previous value. So our range here is actually 0.638. Let's do something like that. Let's just do a 0.63. Will get us right down the middle. Nice and green. That looks perfect. And then again, if you take a value here, we'll do a 0.71. That's outside the range. So there's your color coding. Now, if you inspect multiple times or multiple parts within a group, this will give you multiple results now side by side. So, whoops, I did too many on that one. A couple S's there, it picked it up. Let's go ahead and do a fail. We'll do a pass on this one. That's pretty good. We'll do a 0.315 here. That looks good. And then we'll do a 0.633. That looks good. All right, so these are now showing these different values. Now, when I take this document after doing this type of an input and save this out as an Excel spreadsheet, we'll use a different template. This one's got a little bit more intelligence to it. This is actually going to go ahead and give us now a little bit more free full type of a document, which gives us all of the color codes of the results. And these are all based on something we have called conditional formatting. So if I was to type in a value with any one of these that I was measuring manually, it would be able to color code that with the reds, yellows, and greens as a result of that. So it's a great little bit of feedback that we get. Now, in the event that we're going to use a coordinate measuring machine or digital calipers, we can actually go ahead and use this tool here to add those files. Now, to show you what we're adding here, this is a typical output of what a CMM system is going to give you. This one here happens to be from PCDMIS. We have a lot of flexibility on which ones we use. So in this particular case, you see the formatting has item numbers. It has the nominals, the tolerances, the measurement values, all that information peppered throughout this file. What I'm going to do is use our application to add this file to the system, and not just one of them, but 3 of them. That's going to be 3 different measurement sets of the same document. When we put that in, it simply comes into place and shows us all of that data over here on the right-hand side. So that's going to be things like the character, the item number, and all of the other dimensional values. We can take these and we can assign them in a couple of different ways. Now, auto-assign is nice, but I could go ahead and say, okay, if the item numbers match, which hopefully they do, let's just go ahead and auto-assign those. That's going to overwrite what I did. Now, what we have here is a situation where nothing really matches, and that's more than likely not probable. So what happened with the auto-assignment is that these item numbers were simply incorrect. I'm going to auto-assign this again, but instead of just by searching by the item number, let's do the plus and minus, the nominal value, and the type of dimension, and see if that links them up better. By saying OK on this one and overwriting our previous data, now we've got the greens that we're looking for. So the handshake was a much more proper situation there. Once again, we can take this file, we can save it out as an Excel spreadsheet. What that's going to do is give us a very nice inspection report with all of these colors side by side. So this is the handshake with the CMM data, and that's going to go ahead and format into this table properly. Now, it isn't just PCDMIS that we work with. We can go ahead and modify the settings and actually select any type of template for things like the Pharaoh arm, Medusa, this one up here, Calypso, is the one I was looking for. It's a pretty common one. A lot of different types of tools out there, so we need to go ahead and be able to read in the formatting from each of those systems. All that's very important. So at this point, we're going to switch from the standalone application to the one that's embedded as an add-in directly within SolidWorks. Now, as I do this, what I want to do is mention that this tool is a floating tool. You can go ahead and float the SolidWorks Inspection tool amongst your network using Solid Network License. So it is a very flexibly deployed tool as a result of that. And again, you get both the standalone for PDFs and the embedded SolidWorks add-in when you purchase this tool. So let's go ahead and use this within SolidWorks. I'm going to go ahead and open up an actual SolidWorks drawing. What makes this one a little bit easier to use is that there isn't more or less a recapturing operation that takes place. This is just my EPDM vault updating, by the way. So this isn't a capture in the same instance, the same way that I would do this in the PDF tool. In this case, when I go ahead and take a look at my tab, you can see there's a tab called Inspection. That would be found if you go under Tools and Add-ins and you simply turn on Inspection. But this now allows me to start a new project within SolidWorks, and it uses my Property Manager window here as my tool. Instead of typing in or capturing things like part number, name, and rev, we're actually going to pick the property and link it to an active document property. Therefore, if the document property changes, things like the description would update the part name here in my inspection report. The revision, once again, we'll put that directly in. We've also got some choices about where the actual balloons are going to go, creates instances for each, the sorting order and the orientation, and then what it starts with. We also have things down here for the sampling size. Now, this is something you got to read up on if you're not aware of how this works. The AQL is acceptance quantity limit. I'm going to set that to a number, but let me explain what this number actually refers to. This is going to be a 1% value. 1% of my lot size can fail for this lot to be accepted. We have a document at SolidWorks that explains the acceptance quality limit. And when you take a look at this, there's a simple table here. So the lot size that you're going to grab and the inspection levels, and then those are going to translate over to the amount of items in a sample. So we're going to do a 200 sample. So right here we're going to be using letter G. Letter G is going to be a sample size of 32, and we can have 1% or less of scrap for this lot to be accepted. So find more about these documents, do a search on the SolidWorks customer portal for the acceptance quality limit. So in this one here we're going to take a 1%. When we click Next, we can choose what to extract. Now in this case I can filter it by saying inspection only, and therefore it would filter only things with the inspection bubble around those. But in this case we're going to use all the dimensions. It's going to grab all units, as well as the notes, the G-tile boxes, any type of hole callouts, welds, or surface finish symbols it finds. And then with that, it's going to go ahead and put the dimensions that don't have tolerances and the tolerance limits that we get for significant digits. So things like this 0.75, this one's going to range over here. That should be a plus or minus 5 thousandths. When I say go is when the magic happens, and you'll see everything on the drawing automatically get ballooned, where when we did it in the standalone on the PDF, obviously we were doing that manually. Very, very cool stuff there. So now that we've got this in place, let's go ahead and modify some of the options out here on the screen. By picking anything directly on the screen, you'll see that it highlights over in our Inspection Property Manager. Again, by selecting any of those. If I select it on the screen, or excuse me, in the Property Manager, it's going to highlight out here on the screen. So everything looks very cool that way. It's all categorized by sheet and by view. So if I look at milling and drilling, you see I have milling and drilling tabs at the bottom. On the milling tab, there are several drawing views. So there's drawing view 6 and the detail item number for that, drawing view 5 and the detail items for those. So again, very, very easy for this to do. If you don't want a dimension to be selected, you can simply turn the check mark off and it will re-balloon all the numbers around that. Or if I go ahead and select that dimension again and I did want it selected, I can then turn it back on and it will then re-balloon once again. We're going to add a little bit to this drawing. Let me just go ahead and modify this by throwing a dimension right over here. So when I throw this point, I'll put that up in space so you can see a little better. When I put this 0.93 dimension on there, by clicking on inspection I can hit rebuild, and rebuild will recognize the changes. As a result of that, you see that there's no balloon shown, but if I scroll down on my list here, it's going to be pretty easy to find where that change took place. So there's a reference dimension that it found. Take a look at that pretty easily. If I want that shown, I can simply say selected, and then that will show the balloon and re-balloon what's around it. So changes are pretty easy to assimilate within SolidWorks. Saving this as a PDF is also just a SolidWorks function. So now we say File, Save As. We'll go ahead and grab the PDF file type. And with that, let's view that PDF after drawing so I don't have to locate it. Once we do that, you'll see that the balloons themselves for both sheets will now show up in our PDF drawing. So that looks excellent right there. The balloons themselves are actually on layers. So if we go ahead and bring up our layer properties, you can see that I can hide and show those balloons within SolidWorks very easily. Even change the layer color, which will then change the balloon color themselves. Last thing I want to show you is the ability to go ahead and export this to Excel directly from SolidWorks as well. So we'll also have some templates that you can use in a multi-sheet drawing. We're going to save all the sheets, but this will now save out an Excel spreadsheet with the same inspection reports. First article inspection, that's going to go ahead and correspond with the AS9102 standard. So here's our Excel spreadsheet, and once again, the information that we have there. Now if I go ahead and take a look at one of these, let me see if I can get one. We got a 0.75, 0.77 is the upper limit, so let's do a 0.76. You can see that I have a value there that shows green, and this one, if I do a 0.71, you'll see that this value shows as red. So there's another one of our conditional formatting functionalities if we were to manually fill this out. And that is the SolidWorks standalone application. I'm sorry, the SolidWorks add-in application. So basically what I've shown you over the last half hour is the two interfaces for SolidWorks Inspection, both of which are included with any purchase, and also the professional additional functionality that would interface with CMMs or digital calipers or other inspection types of devices. If you would like an evaluation of this software, please contact your SolidWorks sales rep at Desai Solutions. This is available for evaluation under the add-ins. And if you have any other questions, please get a hold of Desai Solutions. You can email me if you'd like any other information on this presentation. My email is darren@desai-solutions.com. Thanks for spending some time with us and watching this video. Thanks.